This conference will now be recorded.
Awesome. Thanks everyone for joining. And my name is Adam. And today's session, it's more about what is version controlling system, and we'll talk about a tool called Git. Now, pretty much whether you're going to work as a DevOps engineer or as of now in the market, there are plenty of tools that you will be using for your day-to-day work. So being a developer or a QA engineer or a DevOps engineer or a support engineer, we need to kind of understand when we develop some kind of files for automation. Okay. So that could be a text file or a program or a configuration file. So where do we maintain them? Okay. So that is where the Git or version controlling system is not just for developers or only for DevOps engineers. It's pretty much for everyone in an organization where whenever you think of creating some text related files, okay, you should know a process on how you should be developing your file or a code. Okay, so that's what it's all about. So with that, a quick overview, right? So now when you work in an organization, okay, and as I said, you might be a developer where you have to create some kind of program or develop some kind of program that could be in C, C++, or Java, or .NET, or Go language, whatever it is. So what do? You have to create some files in which the code is there. Same way, for your day-to-day automation, being a DevOps engineer or a QA engineer, you might have to create some test cases. So again, you will be creating some kind of scripts or some kind of text file or some kind of configuration file in which you will be storing all of them. Okay. So now again, specifically if you talk about DevOps, whether you're working on a tool like Terraform or Kubernetes or Ansible or Jenkins or Prometheus, there will be a lot of files like YAML files, TF files. Okay. So now in our day-to-day life as an engineer, so you will be creating different files or developing different files. Okay. So now what happens when you start creating multiple files? Okay. Where are you going to store all of them? So typically, you take your laptop or you take some machine in which you do all this development work. Okay. And when you use only that machine and store all the files, what happens? If that machine crashes, everything in that machine is gone because you don't have a proper backup, which is outside the machine. Okay. Now, this is one of the problem where every one of us go through when we are developing some file. Now, again, particularly I'm using this word called developing because it's not just a programmer who will be developing a program. Even when you are creating a script or a text file or a configuration file, you also call it as development. Okay. Now, the second problem that we face is we will not be the only person or a people who will be working on that, because when you say a product, there will be multiple programmers or developers who will be working together to create that single product. Same way, even we as DevOps engineers, you will not be just writing your Terraform code or Kubernetes code or Ansible code alone. There will be multiple people in your team. Together, you will be trying to achieve a automation. So in that way, you will have a lot of complexity, because what if I say there is one single file which is needed for both of you, or one single file is being developed or created by two people? So then there will be a lot of complexity involved, because when you are developing something in the same file, how will another person modify it? Or when another person is modified, how will you change or how will you put your changes? Okay. And not just that, now once every individual creates your own file, okay, Now let's assume if I want to collect all the files and create a product or do some automation, then it will not be easy for us to know which file that you have modified. Out of that, what is the dependency. So that's where when more number of people work in the project, then it will be more number of files. So that is where managing once again all these files with multiple people would be a challenge whenever you are developing something. Okay. Then the third one is, let's say you are working on one of the tasks in the project and you are trying to develop or automate something. Once again, it will not be just a single file in which we will be writing everything. So whether it could be a program or whether it is a script, or even when you are trying to use some tools like Terraform or Kubernetes, you will be developing multiple files. Okay, so that's where, now let's assume you have taken 1 week to develop something, and for that you have created multiple files and you have modified the same file or multiple files multiple times. Okay, now at any point of time, if you want to track what and all you have done, and if I want to particularly find out, hey, can you tell me what this person modified yesterday? Or let's assume that you are developing, you are taking a file, you are writing something, deleting something, and day by day you do the same activity. But you realize whatever you are doing is wrong. So let's go back to everything what you had 2 days back and then redo it. Then assume like when you have multiple files, if you don't have a track on who modified the file, when it was modified, so you don't have the ability to go back to a old content or particularly point to a content. Now, another thing what happens in the same way is when I now take multiple files modified by multiple people, okay, it will not be easy for me to exactly know which is correct, which is wrong, or when we technically talk about a program, if something is not working, how do I exactly identify among all the files I have taken what is causing the problem? So this is when, no matter whether you are a developer or a DevOps engineer or a QA engineer. So when you try to develop some kind of files, these are the challenges that we will be facing. Okay. So this is when, keeping these as the problem statement, what is the solution that we are going to have? So the solution for these problems is to get into a practice. So practice means it's a way how to do things better. Okay. So in order to solve the problems that just now we talked when we are developing some files, is all you have to do is, instead of storing all your code, whatever you are developing, into a single place like your machine, think of having a common location where all of us can store our files or code. Now that could be your shell script or Python script, or it could be a Java program or a C++ file, or it could be a text file, YAML file, any kind of files. Okay. Now in that way, the solution for the problem is you take a common location and try to store all your files. But how do we store? So we should be storing it in such a way, every time someone tries to modify something and put the content back into the same location, you should be able to record what and all changes are happening. So it is like bank. Okay, you put everything whatever you have in the bank, but every time you take something, every time you put some money, what happens? There is a transaction and there is a record. So same way, the solution what we will should go through is, when you are developing some kind of files, don't keep everything in your laptop or machine. Have a common location, and every time someone takes something from that or put something back into it, you need to record those changes. So that way, what will happen? We will be able to have a track on who is modifying, what gets modified, and you have one common location which is available for everyone. Okay, so this is how what you will do if there is a project in which you want to develop some file. Keep a common location in which all the files are maintained. So whenever a user wants to work, he will take a copy of the file from that common location to his laptop or his machine, and then you do the changes. Once you do the changes, then instead of keeping it locally, you should put it back to the same common location, so that every time you put some change back to the common location, there is a track and it has been recorded. So this is how every user will take the copy which is available in this common location. They will do changes in their machine, and once the changes are done, they will be putting it back to the same location. Okay, so this is the best practice that we should follow. So now, being a DevOps engineer or a QA engineer or a developer, anytime if you think of developing some file, creating some text related file, then immediately you should think of this process or approach. Okay, so now this is the method. Okay, but technically what do you call this? So that's where now such a process what we were talking about, in which you follow a practice where you track all the changes that you do to some kind of files, and basically we are talking only about text files, because in a day-to-day work you might be working on a text related file or a binary file. So what do you mean by binary file? A jar or a var, a tar file, zip file, a DLL, all these things are binary files. So what are text related files? Any kind of text file like your notepad, your shell script, Python script, Perl script, your programs like Java, C, C++, Go language, .NET. So all those things are human readable format, right? So anything which is in text file, if you are adapting to this practice where you store it into a common location and keep a track of what is getting modified and who has modified, then we call such a kind of practice as version controlling system. Okay, so in an organization, no matter who you are, when you are developing a file which is a text file, you need to adapt to this process or a best practice called as version controlling system. So what is the benefit you are going to get by adapting to this process? So you will be able to track what changes has been done, who has done it, and when it was done. And you're going to put all of them into a common location so that there is a proper backup. As well as when multiple people are working together, you will be able to do the parallel development. Okay, so especially when there is a project in which multiple people are working, and if there is a dependency, we don't have to worry. This process or practice will help us to achieve that. So that is where we can parallelly do the work even though there are dependencies. And finally, version controlling system also helps us to do authorization, because once again in a project not everyone will be doing everything. Okay, so who needs to do what? Okay, whether you should be only reading the file or whether you should be modifying some file or you don't need access to modify, so those kind of things can be controlled using this VCS. So VCS reference, version controlling system. Okay, so now the first thing clear. So version controlling system is a practice that you should follow whenever you are developing some text files. Okay, now so that's just a quick overview. Now let's understand what are some of the terminologies that we will be using in version controlling system. Okay, now pay attention and understand. So whenever we say a version controlling system, there are two parts of it. Okay, one is called as the client and another one is called as the server. Okay, so VCS works in the concept called a client under server architecture, a very high level. So what is server under client architecture? That's what we will learn. Now the best example that I can give to start correlating is your bank. Okay. Now all your day-to-day transactions that you do, everything will be stored, right? So whether you have your account with HDFC or ICICI or any other bank. So where does it get stored finally? It gets stored in a server, which is maintained by the bank. So now, if you want to do some transaction, so let's say you want to take money or put money, okay, what do? You need a client software. Okay, that client software can be something like your mobile app using which you do a net banking and do the transaction and see the details, or your ATM, right, is also a client. So with the help of that, you log in or you get the details from the server what you need, and you will be able to see your transaction or do the transaction. So that way, your bank is like a server and your ATM or your mobile app is like client. Okay. Now, why am I saying it? So the same way, when you're working on version controlling system, where are we going to actually store all our files? It is going to be in our server. Okay. So that is where you will have a common location called as a server. Okay. Now the server can be a physical machine or a virtual machine, or it can be also something on a cloud. Okay. Because now cloud is being popular. So you can store it anywhere that you want. Now, when you talk about a server, okay, now in your server, all the files will be stored. So just like when you go to a bank, so let's take an example of HDFC. Okay, so now all our transactions are stored in HDFC. However, have they given one account number for all of us? No. So how do we separate, right? So how do we separate a user 1 with a user 2? So there are different account numbers, right? So why do we need that account number? So that we can store all the transactions for an individual into that account and we can track based on that, right? So that way, end of the day, your money is like transaction and it is stored as a account. So what do they have in the server? Different account and its transactions. The same way, when you go to a server in version controlling system, what you will have is files, but there are different projects which we will be working on. So that is where you are not going to directly put all the files into the server. Inside the server, you can think of you will be having different folders. Okay, so that folder is like your account. So each of the folder will be specifically assigned to a project in which you will be storing all the files. Okay, and those folders is what we call it as repository or repositories. Okay, so what will your server have? Your server will have collection of repositories. And what is a repository? It's basically a folder in which all the files for a particular project is stored and maintained. Just like if I go to HDFC bank server, I will be having different folders where each folder points to a account and all the transaction of that account will be stored there. So this is how in an organization there might be multiple projects and different people will be working. And remember, in the server, you are going to have different folders or what we call it as repositories, where each repository represents one project and all the files for that project will be stored and maintained separately. Got it? So this is where logically your server is divided into repositories. Okay. So now, like when you're working or doing some transaction in a bank, so you specifically refer to the account number, right? The same way now For example, I'm working on a project called A. If you want to store and maintain file, you should always refer to the repository called A. Okay, so that you will be able to see the files from repository A, and when you put back the files, you should put back exactly to repository A. So repository is collection of files which is used to store everything for a particular project in your server. Clear? Okay. Now, when you are going to work, okay, so let's assume you went to a company and there is a project already and there is some kind of files available. Now, you might be interested to modify some of the files. So how do you do? So that's where now on your machine, okay, so typically whether it could be your laptop or any other machine in which you are doing the work, so that machine should have a small software called as the client, okay, and the purpose of the client is to communicate to the server and get the things done. Like, why do you need ATM? To help you as a user to connect to the bank server. The same way, the client in VCS is needed to get the files from server and see, and the same way if I do some changes, it should help. With the help of the client, I should be able to put it back to the server. So client acts as a interface between user and the server. Okay, so we tell to the client and client helps us to communicate to the server. And this is when, if you want to see some files, okay, so typically these are files, okay. So now if I'm working on repository A, I want to see all the files of repository A in my machine or in my laptop. So you are not going to just dump everything into your machine. So once again, in your machine, wherever you are working, with the help of the client, you will create a folder, okay, and we will be able to see all the files of a particular project like a repository A into this folder. Just like how you go to bank, there will be lot of ATMs, so you need a particular machine, and in that screen you should be able to see whatever the details is there for your account, right? The same way, in your laptop or a machine, you need to have a separate folder in which you will be able to see all the files that is coming from the server of a particular repository. So such a kind of folder is called as workspace. So workspace means a folder in which I can see the files getting from server, and with this folder I can modify everything, and from this folder only you will be able to put back the changes to server. Okay, so who does all these things is the client. Okay, so what is workspace? Workspace is a folder in your machine in which you will be able to actually see everything. Just exactly like how you have an ATM machine. If you want to see what is there in your server, right? You cannot go to server directly. You need to use the help of a client. So think of your workspace is like a ATM. Okay. Now, okay, so you created a folder called as workspace, and you have the actual files in the server under a repository. Okay, so now let's assume, as I said, I want to work on this repository A. Now what does that mean? I want to first see the files. Okay, so where is the file now? In the server under a repository A. Now that I want to see it inside my workspace or folder in my laptop or in my machine. So like how if you go to a bank, there is a ATM box or an ATM machine. As soon as you go and stand, will it just display that, hey, Adam has come, let me show his account? It won't do. So what do you have to do? You have to do a login, correct? The same way, you created a folder, but how does client will know what files you want to see? So you have to tell to the client, go to this server, and in this server, go to this repository A and get the files and put it inside this folder. So that step is what we call it as checkout. Okay, so technically, what is checkout? Checkout is a process where you take the file from a particular repository of the server and make it visible inside your workspace. So why we call it as workspace is because this is the folder in which you can do the work. Okay. So now whatever changes that you do in this file is being obtained from a copy of repository A. Clear? Okay. So now you will be able to see the files. So unless and until you don't do the checkout, you will not be able to see the files. So in short, checkout is a step which helps you to see the files which is available in the repository and brings it as a copy to your workspace inside your machine. So these kind of work is what client is going to do. Okay. Then you modified your file. Now, end of the day, you are not going to store it locally. So you are going to again put it back to the same repository in the server. So that way, now you will go through another step called as check-in or commit. Okay. So commit or check-in is a step in which whatever the changes that you have done, which is available in your workspace, will be stored back into the specific repository. Okay, so this is how you check out from a particular repository into a folder called workspace. You see the files, you modify the files, and you put it back into the repository using a step called as check-in or commit. So checkout means you're taking from the server to your workspace. Check-in means you're taking from your workspace and putting it to the repository in the server. Okay. So now, every time when a user does a check-in or a commit, you're actually modifying something on the repository or the server. Just like how using your ATM, you take a cash or put some cash, what happens? You are modifying your total value that you have in your account. So for that, there is a transaction created, right? So that's how if I open my bank account, I'll be able to clearly tell whether I got some money inside it or is there a money that I've taken out. And I'll also be able to see what is the total. So the same way, every time when you do a check-in, you're actually modifying something. Because in checkout, what happens? You're not doing anything to the server. You're just taking it and seeing it. But only when you have modified and you're putting it back through a check-in, you are actually modifying and storing it on the server. And this is where every time when you do some change and check-in, there is going to be a metadata created. Okay. So what is that metadata? So that metadata will tell who modified, what was modified, when was it modified. So that way, whether I have one file or multiple files, every time when someone does a check-in, the version controlling system will collect the details on who is modifying, what file was modified, when was modified. Exactly like how if I remove $1 or 100 rupees from my account through an ATM, it is exactly going to tell who removed it, at what time it was done, and when was it is done. Okay, the location. So the same way in VCS we are talking about text files. So every time when you do check-in, a metadata will be stored. And in fact, in bank you call it as a transaction and a transaction ID, whereas in version controlling system, that metadata that gets generated when someone does a check-in is what we call it as version. That is why we call this tool or concept as version controlling system. Okay, because end of the day, when you go to your bank, do you think they are actually keeping money? No. What do they have? It's full of the transactions. So what does your bank server actually is having? Full of transaction. They are not keeping physical money. Same way, when you now go to a server in VCS, you are not actually storing physical files. You are storing only the metadata. So from that metadata, when you do a checkout, it is the responsibility of the VCS system to show you the file contents. Okay, so that's why it is easy for us. So this way now, as a user, if you are working on a particular project, you need to first make sure there is a repository for that in the server, and in your client create a workspace, do a checkout so that you will be able to see the files particularly from a repository inside your workspace. Okay, and then once you do the changes, if you want to put it back, then do the check-in or commit, and every time you commit there will be a metadata or version will be stored, and this way remember the metadata or the version is specific to repository. So like how you have a bank account, even though you can have two accounts in a bank, the transaction that you do in one account is not visible on another account by default, right? So the same way, anything that you store in one repository is specific only in that repository, and it will not be visible to another repository. All right. Okay, so these are some of the technical words that you should be remembering as we move through. Okay, so a server is a place where you store all your files, but inside your server, where are you actually storing it? In a repository. So your server will be having multiple repositories. However, for a user to work, you need what we call it as a client that is installed on your laptop or a machine. Now, if you want to start doing some work, first you need to create a folder called as Workspace, and in that you will be doing a step called checkout, using which you will be able to see all the files of that repository. And then once you see the files and you have modified, and if you want that new modified files back into the server, then you do a step called as check-in or commit. And whenever someone does a commit, it will be creating a metadata and storing it as a version. Like how your bank account has transactions, IDs, the same way your repository in a server contains different metadata called as version. So this is how we will be able to track who modified, when was it modified, and what exactly was modified. Even if you put a dot into a file, it will be tracked. Okay, cool. Now, so this is just a terminology. Now there's another thing that what you need to know is, so when we are talking about this client and server architecture, this is one of the method in which VCS works. So this method is what we call it as centralized version controlling system. So I'm talking about the architecture of the two. Now, centralized version controlling system is one of the oldest architecture, because VCS is not something new. It's there from a longer time, even more than a decade. Okay, so now whenever you say a centralized version controlling system, so you will have one common server which is centralized. Centralized means it's common for everyone. Now what happens when a user wants to work? The user has to make a checkout, or what we call it as sync in different tools, so that you will be able to take the files from the repository and put it inside your workspace. Okay, and then what do? You modify the files and you check in back. Okay, now like this, every user will try to check out the files into their workspace in their laptop or machine, and whenever they want to submit the changes, they will be submitting it back to the central location. Okay, now why do we call it as centralized? Because whenever a user is trying to store and send the change, there is one common location which everyone will refer. Because if you want to work or another person wants to work, from where are you checking out? You are checking out from a common location. Now, what are the disadvantages in working with this system? So the first thing is, your central repository is once again just a single point of failure. Why? Because what happens if your server crashes? There is no other backup that is available. And if you are a user and you need to be connected to the network and you should always be online, correct? Now for some reason, if you are offline, what do you mean by offline? You're not working on internet, okay? Then can you still do some change and put it back, or can you still see some change? That is not going to be possible, okay? And what will happen in the centralized model, when a user does a check-in, okay, it directly goes to the central repository. So this is where if a developer does some mistake, assume he put in some wrong code by mistake, okay, then what is happening? It is visible to everyone, because if you try to do a check-in and after that if someone is trying to do a checkout, so whatever the wrong code or the file that you have put is visible to everyone. So if a user wants to store his code, he has to do a check-in, but as soon as he does a check-in, it is going to be in a common location, it is visible to everyone. So there is no way you can have a control where can I store my files only for my purpose? Okay, so that is not possible because everything is getting stored into one common location. And another biggest problem here, what you're going to have in centralized model is the process of checkout and check-in will be very, very slow. Just like you go to ATMs, you see network is slow, right? Because now you are working on a machine in which client is there and server can be on some other location, or your repository is on a server on some other location. So the concepts or the steps called checkout and check-in will be taking a lot of time. So that is where working in VCS will be slow. And as we are focusing in DevOps, right, we need everything to be automated and we need everything to be done faster, and it should be simple. Working in a centralized model will not be flexible for developers. Why? Suppose, let's assume when you are working in faster releases and there are many releases working at the same time. Now I have modified a file and I want to share my files not with everyone but only to a particular user. Then what happens in centralized? Whenever you do a check-in, it directly goes to the repository and everyone will be able to see. Now, if you want to share only with another person, or if you want to take the changes only from another person, it will not be possible. So that's where the workflow is going to be very rigid. And this is where now we need a version controlling system which is simple to use and it is flexible, okay? And that's when the new model in version controlling system is what we call it as a distributed model or distributed version controlling system, okay? So what do you mean by distributed version controlling system? So pay attention. Now, even in the distributed, you are going to have a repository, which is in the server somewhere, which is common for everyone. But the difference is, unlike the earlier method, in distributed version controlling system, what happens is, you will not be just doing a checkout, but when you start working, you take a kind of complete clone of the repository and put it into your machine. Like, think of it something like this. I install a ATM machine in my home so that anything that I need, I don't have to go to some place and do all this activity. I have an ATM with me any point of time. Okay? So this is where what happens now, or the best way that I would say is your mobile app, right? So now you don't have to go and wait for some other place. Take your mobile, instant login and do the transactions what you want. The same way, now in a distributed, what happens is you are basically going to make a clone of your repository. What do you mean by clone? Copying. So whatever is there in the repository, you will also get everything into your machine. So this is where in distributed version controlling system, if you want to start your work, the first thing you will do is you will do the clone. So when you do the clone, you will get a copy of the repository into your workspace. Okay. So now you have actually made a copy of the repository. So if you want to now see a particular file, you have to do a checkout, right? But now, where is the actual files? It is not on the server. For you, it is available in your workspace. Okay. So now, if I want to see some file, I should go to the workspace in my machine and I will do the checkout. Okay, so basically now the checkout is not happening between the server and your workspace. Your workspace already has a copy or a clone of your repository. So all you have to do is choose what files you want to see within that workspace. Okay, so that is where checkout will be faster because you are seeing everything on the same folder. And once you modify, you do a check-in. Once again, in the centralized model, when you do a check-in, where does it go? It goes to the repository. Where is the repository? Server, which is common. But now, in the distributed model, you have your own copy of the repository. That is why we call it as clone. So, you did the checkout from your local copy, and now if I modify and check in, I will be checking into my local copy of the repository. So this is how checkout and check-in will be very, very fast. And the other benefit is now, if I check in some files and I'm storing it, where am I storing it? I'm storing it only locally. It is available only in my workspace. It is not visible to everyone. So this is a greater benefit for the developers because I can share the changes only when I want. But until then, I can do check-in and store everything into my local repository, which is a copy of my central repository as a clone. So this is the difference. So in your distributed model, you will get a copy of the repository locally. So you will check out and check in everything from that locally. Okay. And then when you want to share the changes to everyone, what will you do? You will push the changes from your local repository or basically the workspace back to the central repository or what we call it as a remote repository. Okay. So this is the same way. Now, if another user wants to work, they will do the clone. So they will get the copy of whatever is available in the central repository to their machine, but they are not going to just get the file. They will get a complete copy of the repository. And then they can go ahead, check out the files, modify and check in, and everything will be stored locally. Okay, and then they can share the changes back to the server. So that is how you decide when you have to share. But until then, everything is stored in your local machine. So the benefit, if you see, you have a local repository in your workspace. Okay. Now this is when, if I want to update my workspace. See, the first workflow is you clone, you modify everything, and whenever you want, you will be sharing it back to the server using push. But after some time, if someone else has done a push and stored the file, it will be available only on the remote repository. It will not be available on your local repository. So once again, you should not be doing a clone. What you should do is called as a pull. So pull means update your workspace or sync your workspace. So this way, in distributed model, you can pull a code and push a code. Okay. So pulling the code can be from a remote or a central repository to your local workspace, And pushing will also be from your local workspace to the remote. So this is one way. However, I told you some time back, what if I want to share some changes with another developer or another user, but not to the central repository? So that's where what you can actually do in distributed model, you can pull or push between two user repositories also. So it is not mandatory that you should always pull from central repository or push from central repository. You can also pull a change from another repository which is local and push it back to another local repository. So that's why it's called as distributed. Okay, whereas in central, every time you push, you're actually pushing only to one location, and whenever your readings, that is checkout, you're always getting it from one location. Whereas in distributed, in the beginning you make a clone from your central repository, but after that, if you want to share some changes, you can choose whether I should share it to everyone, then I should put it into remote repository or central repository. But if I want to share it to another person only, then I can pull or push the changes only to a particular person's local repository. So this is where the benefit what you get in distributed model is all your changes are stored locally, and then you decide whether you want to share the changes to an individual person or with everyone. Okay, so that's how the workflow is faster, because you already have a local copy. Okay, so the checkout and check-in will be super fast because it's like you are carrying your own ATM machine. And it's also flexible because I don't have to share the changes only to central repository. If I and another person are working, we can share the changes among us, and then we can decide when to share it with others into the central repositories. And another biggest benefit what you have in distributed model is you can work offline. Why? Because here, once you do a clone, you don't need a server. So when do you need a server? Only when you are doing some pull or when you are pushing the code back. But until then, to do the checkout and check-in, you already have a copy of the repository locally. So that is where it gives a greater benefit for users or developers where you can also work offline. Got it? So now in DevOps, working on version controlling system is not sufficient. We need to work on a distributed version controlling tool or a system. Got it? Because it gives us greater flexibility. We can work offline and a user gets a complete copy of the repository locally. Okay. So again, just to recall, so you will have a remote or a central location in which you will be storing all your files. Again, this repository will be in a server. So to start the work, you will do a clone. So when you do a clone, you will get the complete copy of the repository locally. And from there, you check out and you check in or commit. And then you decide whether you want to push or share it to central repository so that everyone will take, or you can share it to an individual of your choice. So that's why it's called as distribute. Whereas in the previous model, everyone will store it into one location. That's why we call it as central model. Got it?
What if there is a dependency between the codes?
Yeah, we'll talk.
Ambiguity.
We have it. We'll talk about that flow. This is just from a high level. Okay. Okay.
So here it is going to be the working copy and the local repository are two different folders in that particular machine.
No, I'll talk about that. Okay. As of now, all you have heard is one word called workspace, right? What is a workspace? It's a folder. We'll get in deeper. So all of now I'm just trying to tell you is what is distributed and central version controlling system.
So push and pull is something like chicken and checkout. It's the same.
No, there's a difference. So that's where if you look at the diagram, pull means you're taking the code from central repository to your local repository. Push means you're putting the code from your local repository to central repository.
That is different from check-in.
Yeah, that is what. What is checkout? You're taking the files from your local repository only within the workspace to see what files you want. Whereas you modified something and you want to store it back into your local repository, then it is called as check-in or commit. So the activity between the central repository and your local repository is called as pull and push. Within your local repository or within your workspace, to see the file and to store the file, you use checkout and check-in. Okay. Now why we added this? Because in the centralized everything is directly, whereas here you need to clone and separately. Now there are two repositories available. Okay.
Terminologies are different from.
Yeah. So it's because the reason I came here is first you need to know what is VCS, and then specifically we're going to focus more into distributed. Again, in an interview, if someone asks, you should be clear on what is that you are using, why you are using. Okay. Now let's get deeper into it. As of now, we are talking only about the terminologies and how the model works. And coming with this, so now, how exactly do you implement this version controlling system, which is a distributed version controlling system? So there are many tools available in the market. Out of that, one of the popular tools that we have is what we call it as Git. So now if someone asks you what is Git, so Git is a tool for managing or doing the version controlling of all the files that you have in a project. Okay, and typically Git works in a distributed version controlling model. Okay, or in a very simple way, Git is a distributed version controlling tool using which what you will be able to do, manage projects in which you will be maintaining text files. Okay, so remember again this word text files. So using Git, you will not be storing zip file, tar file, jar, and var. It's only text related files. Okay, and now in Git, everything is a workspace, because if you actually see in your local, you have a copy of your repository, but it is technically only a folder called as workspace, but inside that you will be having all the contents. We will see it a little later. So that is how every user, when he does a clone, you will get a workspace inside which you will have a copy of your repository, which is called as local repository. Okay. Now, it's not just Git, there are many other tools similar to that, but however, one of the popular tool that we have is Git. Okay, so now clear? So in a company, now everyone needs to work on a tool like Git, and even we as a DevOps engineer will be creating some text files, configuration files, scripts. So we should also use Git and store all our files. Okay. Okay. And once again, now let's understand something important. So I told you that what is the architecture of VCS? You have a server and a client. So the same way, so when you're working on Git, Git also has server and client. Okay. So typically on your machine, you install the client, right? So that client or that CLI means command line utility, right, is actually called as Git. What is it? The actual Git what you install on your machine is the client side. So that means there is also a need for a server. And that is where in Git, there are a lot of other softwares or tools which acts as the server. Okay, so some of the popular examples for them are GitLab, GitHub, Bitbucket, Gerrit. So all these things will help us to act as a server. For what? For the Git. So this is where now, if you go to any organization, they will be choosing a server which could be like GitLab or GitHub or Bitbucket, and this is where all your central or remote repositories will be stored and managed. However, as a user, when you want to do all your work, like I said, cloning, pull, push, checkout, check in, or share the changes. So for all those things, you need to use a command line utility which is what we call it as the Git client. Okay, and using this Git client, you will get the copy, modify the changes, and put it back. So that way, when you now start working, you need to have a server and you need to have your client. Okay, so that way our focus will be more onto the client side. So regardless of whatever server you have, you need to now install Git client on your machine and you have to start interacting to the server. And in this sessions, I'll be completely talking about GitLab as one of the server. Like this, you can refer to any one of them which is available. Okay, so clear now? You have a server and you have a client. So when we say Git, we are talking more about the client side. Okay. All right. So what will you have now in GitLab or GitHub? You will be having the central repository, or now we should not use that word called central because it will be confusing. That's why they named it as remote repository or a common repository. Okay. So what does your GitLab or GitHub contains? Remote repositories or different projects. And what will you have on your machine? With the help of Git client, you will be able to get the copy of the repository files, modify and see them. Getting it? So that's where you have server and you have client. Okay. So pretty much now we have understood what is version controlling system and what is Git in that. Okay. So now let's try to set it up and see how things work.
Uh, Sorry. So between the users, we have pull and push, right? So it would be for local repository or workspace to workspace.
Yeah, I'll tell. We'll get into it. As of now, it's workspace. Workspace to workspace.
Working copy to working.
No, don't worry. That's a different. The word that's why I'm saying workspace. It's between workspace to workspace. One user's workspace to another user's workspace. But let's get in deeper into it. So now, if you want to start working, what and all you need? You need server as well as client, right? So now, as I said, let's set up a server. Now for this, you can make use of GitHub or GitLab, but I'm just preferably using GitLab. Okay. Now, GitLab is available in cloud form. Okay. So one of the reasons it's popular nowadays is because it's also available in cloud, so you don't have to install it anywhere. Now just go to gitlab.com, and if you do not have an account, create an account. Okay. Now I've already created it, so all you have to do is go here and click and give your Gmail or any other email ID and create a account for yourself, so that you can also store your remote repositories into GitLab for free. Okay. So once you have created your own account, you can sign in. Okay. So here I'll just use my login where I've already registered. Now once you go to GitLab, now GitLab is the server. So it will show you all the projects that is already available. Now in case if this is the first time you are creating your account and going to GitLab, you will not be able to see anything, don't worry. But now what we should do, first create a project, or what we call it as the repository, right? So that I can store all the files that is needed for my project. So that way, for us to work, now I need to create a repository, or technically in GitLab it is called as a project, because project refers to a repository. So to create, all you have to do is click on new project. All right, I'll create from blank and give a name to it. Okay, so we'll just call it as my awesome project. Okay, so this is my remote repository or the repository which everyone should refer. Okay, now there are two options here called as private or public. Now public represents anyone who logs into GitLab will be able to see, and private represents that what only if I give permission you will be able to see. Now this is where once you start learning the server side of GitLab or something similar, you should be able to understand all these things. Okay, so pretty much here, again, for you to get focused on the Git client, you need your own repository so that you can work. So that way, create a private repository, come down and click on, okay. Now, so in my case, I already have created lots of group. So you don't have to worry. If it's the first time, it will not ask you all these things. You can just go ahead and create it directly. Okay. All right. So what did we do now? We created our repository inside the GitLab server. Okay. Now come down here and click on this clone option, and you will be able to see two options. You can choose any one of them, but preferably take this clone with HTTPS. Okay. Now let me copy this to a notepad. This is the location of our remote repository. Okay. So now if a user wants to do the changes or see the changes, they should be referring to this particular repository. So technically this is the URL in which our central, or let's not call it as central, we have our remote repository. Okay, that's it. So again, let's not get too much into the server for your basic practice. So you needed a repository, which is the remote repository on the server. So this is your remote repository. Okay, so let's just mention it, remote repository. Okay, what's the next thing that you're going to do? Once you have set up your server, the next thing you need to do is set up your Git client on any of your machine or laptop. So typically, let's say you're going to work on your laptop, which is Windows or Mac, you can install and set up your Git, okay, which is the Git client. So now, if you want to download Git client, go to Google and just search for Git download, and you should be redirected to a URL called gitsem.com. Go to this, and here, depending on which OS that you're working, you can click and download the version. Or suppose if you're working on Linux, you will also get the commands what you need to run, typically based on the operating system flavor. Okay, so whether it is CentOS machine or Ubuntu machine or Fedora, you have different commands. Now again, I'm focusing on Windows, or most of us will be having Windows. So all you have to do is, if you have Windows, click on this and it will download a exe file which you need to install. So depending on what machine you are working, you install Git. Now what is that we are downloading? It is the client. Okay, so server is your GitLab. What we are trying to download is the client. Okay, on whatever machine you want to work, you need to download and install the Git client. So now anything that I download on my Windows goes to a download folder, and here you can see there is a executable. So double click on this. Just go ahead with the default options. Okay, Now, don't worry about any of those changes. Just go ahead with default. Complete your installation. That's all. Yeah, if it's Linux, it's pretty easy. You just have one command like apt install git or yum install git. Okay, so depending on the OS. For Windows, download this exe and install it.
We get pluggable version.
What do you mean by
Folder,
pluggable?
we want-
No, it's not like that. For each of the OS, you need to install it separately. All right, cool. So now you have installed Git. Now, if you go to, now I can launch it here. If not, meantime, I'll just show you. So in Windows, okay, if you go and type for Git, so you should actually see three things: Git UI, Git Bash, and Git command. Now take this Git Bash. So what is this Git Bash? So Git Bash is a command prompt. Like how in your Windows you have your DOS command prompt, Git Bash is also a normal command prompt. But the benefit of this command prompt is, apart from running your Git commands, it helps you to run your basic Linux commands because it's a Bash command prompt, not a DOS. So using this, what you can do, you can run all your basic Linux commands on top of your Windows, plus you can also run your Git commands. Okay, so preferably if you're working on Windows, always make use of this Git Bash. Okay.
In Linux machine also this.
Yeah, in Linux machine, you don't have to do all those things because Linux already has the Bash, okay, or your operating system itself is Linux. So you can take your terminal directly and start working. Whereas in Windows, you get this additionally called as Git Bash. Okay. So now all we did is we installed Git client. Now to cross check, you can just type which Git it's available, and you can also say Git version. So we have installed 2.39 on Windows. So we have Git client installed on this laptop. Okay. Now, what's the next thing that you have to do? So whenever you have installed Git client, for the first time, you need to do something called as setup. Okay, because Git client should register as what is the user who is going to do all the activity on this machine. So that is where there are some configurations that you have to do. So typically there are three important configurations that you have to do for the first time on any machine when you have installed Git client. Okay, so what are those? So there are three commands. Now, generally, anything that starts from dollar is indication that it is a command. So don't think you have to put dollar. So dollar indicates here that you are typing a command here. Okay. Now, we will be using this Git client or this CLI to interact with our server. Okay. So what are those commands? We will see. But today, now let's first understand what you have to do. So there are three configurations that I said, and these three configurations will be global configurations. The meaning of global is any person now they join, kind of connect to this machine and open the Git command prompt, it should be applied globally. And I can also have multiple workspace on this machine. So whatever workspace I go, it should be the same configuration. Okay. So git config global, what you're going to set. So three things. First, set your username, user email, and there is another option called as push.default. What is that? We will see. So first, username and give your name. All right. And then you're going to say git config global user.email And when you go to your organization, this should be your official email. And then the third one is, okay, is simple. Right, so we'll see why we are putting all those things in a while. So now run all these commands on this command prompt. Okay, so then okay, so here whenever I open my command prompt, that is the git bash command prompt, it will know the username as Adam and it will know the email as SEM Learning Center. Okay. So now we have done our basic Git client setup. That's all. So we have the server which is on GitLab, and in that we have created a central repository or remote repository, and we installed Git client on our laptop wherever we want, and we have set the basic things. Okay.
Can we create only one user?
Yeah, at a time only one user, because you have to track everything as one user.
Let's say if I am practicing in my
No,
local
you don't need to do that. That's what I'm saying. In the bank, one account will be identified using one username. Okay, you will not be having multiple username to track. So that way, this is main for identifying. I'll show you why you need it. Okay, so it's always just one person. So clear? So we set up the server, we have set up the client. Okay. Now what's the next thing that you are going to do? Now this is where, now let's go to the next class. We'll see everything once again, where I'll tell you what is the need for that username, what is that push that you used. Okay. Why do we do this pull and push? But any questions on?
Adam, do we get this record session?